Let me first say hello to all Adam Smith seminar followers. And let me say additionally, 3 days before, Merry Christmas to all of you. So this session, I have the honor to introduce Gregor Berz. He's our moderator since many sessions, and he's also our speaker today. And first of all, let me say, besides all economics, Gregor and I, we were friends, or we are friends since a bit more than 10 years, and we share a common hobby. We are keen of sailing, and especially dragon sailing. What you perhaps do not know, Gregor Berz is the chairman of all dragon sailors in Germany, a big boss of all dragon sailors in Germany. So some years we went to competition. We both went to competitions on the same boat. And meanwhile, it's about 5 years, we are competitors on 2 different boats, but nevertheless, we are friends until today. So let me now change a bit to the professional, to some professional aspects of Gregor's life. Gregor has a background as a mathematician. And after his study in Augsburg, he also achieved a PhD degree in mathematics, solving very abstract questions of algebraic number theory, a special branch of mathematics. Gregor's professional career was devoted to market economy, but different to some of you, not only by thinking about markets like scientific observers mostly do, but by diving deep into the market dynamics and taking their responsibility as an acting, as a designing, and as a decision-taking part of this market system. He started his industrial career at in Germany well-known company Giesecke & Devrient. They produce our euro banknotes. This is a producer of banknotes where he was concerned with security problems. From there, from Giesecke & Devrient, he changed to the consulting business, first with Arthur Andersen, where he introduced typical controlling and optimization tools at his clients, industrial clients, normally industrial clients. So 2002, some of you remember there was a breakdown of Arthur Andersen. After the breakdown of Arthur Andersen, he joined a startup specialized to game theory. And this was the starting point of many years of dealing with questions of the practical application of game theory. So in 2007, after leaving this first company where he was concerned with game theory, he published his book, Game Theory, Auction and Bargaining Strategies. And direct after 2008, he founded IFAMD. This is the short name for Institute for Applied Mechanistic Design. And this company works as a basis of his own consulting business, which is started at these days with focus on game theoretical applications. IFAMD was since that time basis for many consulting projects in industrial pricing and bargaining processes, as well on both sides. This means as well as the sales side as on the purchase side. So you know there are always in industry 2 sides in a bargaining process, the sales side and the purchasing side. As an example of an very exceptional project was the auction design of the audio visual rights in the German soccer league. And he got this project in 2012 and again in 2016. So besides his focus on application of game theory Gregor did not neglect his theoretical background. So he published 2015 a paper together with Manfred Holler, with the title The Dilemma of Renewable Energy. And meanwhile, he works additionally as a lecturer and adjunct professor at Kutaisi, I don't know how to speak it, Kutaisi International University. So in 2021, yes, Gregor Berz published another paper with the title How the auction cube supports the selection of auction designs in the industrial procurement, where the auction cube is a practical tool for faster finding a suitable mechanistic design. And this auction cube and this last publishing gives now the background to his lecture today. So Gregor, the stage is now yours.
Thank you very much. So we can't hear your clapping hands, but I say thank you very much, Helmut, for this very kind introduction. And I do not only say thank you for your introduction today, but also for your introduction to this community at all 10 years ago, because you introduced me to Manfred, and without you, I wouldn't be here today. So, and of course, I thank Manfred for this opportunity to share my thoughts here in this circle. And for that, I would like to share now my PowerPoint slides. I would like to talk today about the auction tube. It's an invention I was driven to by a client some years ago, 2017 this was. This client was Hilti. Brian Sieden is supposed to probably join us here also today. I didn't see him yet, but he also wanted to attend. And Florian Rupp, you all know, also from the Center of Conflict Resolution. These three together developed this year this little paper about the auction cube, which is kind of a scheme how to design auctions in very easy situations. And it is kind of the way of my thinking since about 15, 16, 17 years, how long I do auction designing in practice in industry. And so thoughts are kind of repeating in any sense. Of course, every project is tailor-made again, but the thinking is very similar. And yes, the story behind was that Hilti or Brian Sieden one time said, we now really have to bring it into a scheme so that it is not so arbitrary. It looks like arbitrary and every time a new idea. And that's something I really don't like if I look at my competitors, if game theorists in practice start to kind of gamble and almost gamification doing in trying out all the time anything new. I subsume for myself that I can argue for or can motivate for the solutions I recommend, and those ideas then brought together into a schematic solution was the auction cube. So let's just look on the agenda. 7 topics, actually 8, because before we even go into the agenda, I have 2 more slides just for the notations of today, and then a motivation, a short why an auction cube at all. Then the preconditions. The auction cube is only for very simple situations, and in more complex situations you still can use it as a nucleus of the thinking, but then things become more complex, of course, and you have to combine things again. But for the most simple situations, it's straightforward. And so first about the preconditions. Then about the basic auction types the auction cube uses. This means the basic auction type is a single auction fast, so to say, which basic auction type is used, like English or Dutch or whatever. And the auction design is then already a combination of those. So the auction cube recommends then in different situations certain auction designs. The core of the mathematics in this paper is then chapter 4, the fundamental trade-off between first price and second price auctions. This is, of course, the main thing that has to be decided whenever it comes to auction designing challenge. Is it more of a first price or more a second price situation, and what should be the final decision round and so on. So here I'm doing a little bit of mathematics, just very primitive in your level, but yes, still some formulas and something which could be of interest. And then we have to talk about the revenue equivalent theorem, of course. And what I want to say is that the auction tube kind of turns it around, how Milgram motivated is with a very famous quote, that the reason why it is in practice not fulfilled tells you what to do. And this is exactly the thinking behind the auction tube. Then chapter 6 is really going through the 8 corners, so to say, where are the recommendations and what is recommended. And the nucleus of all thinking is the famous Klemperer auction. I will tell who doesn't know it anyway, what the Klemperer auction is, and then the adaptations of that are in the corners of the cube. And at the end, a small conclusion or prospects also. So before we even go to the first chapter, just 2 slides about notations. So this is something I guess for all of you is very clear. As a game theoretical view on price negotiations or negotiations at all, yeah, especially price negotiations, that there is a zone of possible agreements, the SOPA called also, or game theorists just talk about the separation, or how to share the pie, so to say. And this is a range between the 2 indifference levels. And the important thing here is this indifference level is something which normally also is referred to as a reservation price. So economists typically call it a reservation price. This for us today is just synonym. The reason why I call it indifference level is because if one of the 2 sides is an auctioneer and executes an auction, then the reservation price typically is a certain price level in this auction. And for the other side, is a kind of, in practice now, kind of uncommon to call it reservation price. Of course, it's also kind of someone reserves the right that a bid is not probably valid below, or he wouldn't even bid there, but it's more something like an edge below which he doesn't bid, if it is from the vendor side, the bidder. And it's just a common language. But for you, wherever you read today indifference price, just think about reservation price. It's the same. So for us today, we talk more about auctions than about bilateral negotiations. And for us, because I apply it in industries as auctions on the procurement side, even if I'm on the sales side, then I'm on the sales side in preparing us, my client and me, as a bidder on an auction of their client. Yeah, so in industries, it's typically to have reverse auctions, where the buyers are the auctioneers. So when Helmut told you about the license auctions of the soccer league, and then this was exotic for me because this actually was a sales auction. For you theorists in game theory literature and auction theory literature, of course, their auctions are all the time described as sales auctions. So please forgive me, but today you have to switch around, and I typically talk about procurement or reverse auctions today. So typically it's the buyer is the auctioneer, and there are some vendors that bid in such a tender. And this is the second slide concerning nomenclature or wording. This is an original slide from my sales workshops. This is very important if we talk with bidders on the vendor side, on the sales side about bidding strategies, then to differentiate between this indifference level, which is a reservation price, so to say, and what is really offered as a bid in any kind of auction situation, depending on which auction type or which auction design or auction mechanism it is. So if this here is in blue, like start and an arrow going down, since this is already kind of indicating that you could think about an English auction or a discounting auction where prices go down, then at the end probably an indifference level is straightforward. We all know truth-telling mechanisms, bidding strategy, but it is completely different if we talk about a first price auction. Then we would never bid the first price level, because this is per definition where it doesn't matter if we win or not. So we will want to have some strategic margin. And the big thing is, how big should this strategic margin is. So to some extent, the bidding strategy is a no-brainer in a second price auction, and in a first price auction, it becomes really demanding to know about their own estimation, how strong are the competitors, and their own risk aversity. So risk aversity for us here today, another synonym, economically we would call it risk aversity, but in practice we call it typically the strategic relevancy of the business for the bidder. How important is it for him to really get hit, or how much is he risk neutral against the risk that he doesn't win the business? So this is synonym for us. And another topic is that we are already mentioned. We talked today about typically the auctioneer being the buyer. Yeah, the indifference price is completely independent from the negotiation mechanism. And the negotiation, this word is a kind of artificial. That's something I actually also have a trademark on, negotiation process, a process which is both a negotiation and a decision. This is a very big topic for us in practice, that in industrial negotiations, we really have to make sure that a decision is driven by such a mechanism. And we differentiate, for instance, between an auction and a bidding. We call it only an auction if it really drives the decision. And if this is in doubt, or probably, yeah, the buyer even doesn't want to decide yet, he just wants to have a price benchmarking, and then this is a bidding. So even wording, we differentiate, but that's a topic that for today is just assumed that we all the time also talk about the decision. Yeah, the other point I wanted to make here is that the strategic margin is something which is highly dependent on the negotiation mechanism. Yeah. Meanwhile, the indifference price level is completely independent from what happens in terms of mechanism. The strategic margin, of course, as we see here already, comparing between the first price and the second price auction, this depends completely on the mechanism. And this is the value capital M that we will see later in the formulas very often. The M, the strategic margin that a bidder would bid in addition to his indifference level or his reservation price. Yeah, and the last bubble here is what I already mentioned, the decision commitment. Big topic for us in praxis, is no topic for today. I just mentioned it now. Decision commitment is assumed to be just given for today and never talk about this again today. So motivation. I have to double check if Brian Sieben is in, because the second next slide is actually from him. Is Brian in the call? No, he didn't come. We can, yeah, doesn't matter. So this is the next slide. He was actually painting years ago after we did the auction tube, when he did talks in Ariba summits and so on. It's a big challenge for buyers, yeah, supply managers in industries. It's the auction tools, so it's electronic tools to provide platforms where you can perform auctions. They overwhelm them with different kind of auction designs. English auction, of course, Japanese auction, Turkey auction, Dutch auction, Brazilian auction, whatever all this is, yeah. And it is completely, they don't see the wood because of the trees. And now it is really the motivation for the auction tube finally to bring here a structure in. And the point is that we take really now help from two famous game theorists, Milgram and Klemperer, and the well-known practitioners. This is me. Also, there's a little book. Of course, not on ITI level. It's a completely different level of book. But I use then those two argumentations, the Klemperer auction adapted in the corners of the tube, and the thinking of Milgram with his famous quote in turning the revenue equivalence theorem around or reverse, to bring up a scheme with clear conditions, selection criteria. The auction process is clearly advised, and it's even for a legal framework. We made it, and that's why those two slides, the last one and this one, we're going to Ariba Summit several times already via Brian Sieben, because we did it as a part of the Ariba terms of use together with this decision commitment, which I mentioned. Now I mention it again. I promise not to do it, but these are the big things that are able then with our tube. So a very first view on it is this. We will go to the depths now for another hour or so, but or 3/4 of an hour. But just at a glance, there are some preconditions have to be met. The preconditions essentially that it is an easy standard situation. And after, if they are met, then the selecting of the auction design is straightforward according to three other diameters then, or coordinates. So these are not the preconditions. These are then the other three conditions that are to be evaluated in order to come up then with an option design. So we will discuss all this, but now first, oh, this is the tube itself. Here it is. Can you see it? This is how the tube is looking like. It's the same. It's a diamond somehow, but the thing is that just the edges are cut, and on this triangle that come up, if you cut the edge, then there is a recommendation on. So that's why this is exactly the same like this. So the dark red is this edge, so to say. So preconditions. They are very important, and they are not only important in order to apply the cubes. Those are the topics which are important in any project we do, especially if we address on the procurement side in order to prepare tenders in auctions or similar game theoretical optimized negotiation and decision processes. And the first precondition to apply the auction tube is that there has to be competition at all. So it's minimum 2 or better 3 or more suppliers or bidders. If there are 2, they should know that there are 2 of them. Yeah? So a transparent duopoly where they know that there are 2 of them, I would not go into the auction recommendation. So we should think about something else. How to we really have to evaluate if it is then still a Dutch auction or something that we can do, but certainly not with 2 phases and probably just 1 phase. But it depends on if there is really competition or not between the 2 of them. And this is something we really have to talk about for some minutes still, is there must not be any collusion in that market between the bidders that are endowed. Collusion is a big topic, so this is a precondition that we can really assume that there's no collusion. The second precondition is that the suppliers have to be equivalent, and equivalent means actually 2 things. One is that they have to be comparable with their offers, with their performance, with their products they offer, and as a company then also all aspects which are decision relevant, we have to be able to make them comparable. It is very important for us that we do not talk just about the price. We talk about the price performance ratio, but how is this performance ratio then mapped into a decision price? And the second thing is that, of course, this strategic relevancy of the business for the bidders, if it is high or not, might be different, but it should be the same for all the bidders. If it is asymmetric, then it's also not so easy, so straightforward to call up the auction cube. The auction cube assumes that for the whole market overall, for all bidders that take part, this strategic relevancy, or call it risk aversion against not to win the business, should be equivalent. So about this topic, comparability and the bonus system, we have to talk 1 slide long. And then there's a last, more technical thing. It's about a single unit or a single object. We call it typically a single lot in terms of business. That it was put out to tender or so. As an auction cube is applied to single lots. If we have several lots, then and it's the same bidders being out for several lots, then it gets a little bit more complex, combinatorial issues and so on. Then still the auction cube can be applied for the single lots, each single one, and then it has to be combined. But first of all, it's just thought for single lots. So about the collusion, just some small slides. You know, from literature, typically game theory literature talks about the fuel prices and not only the consumers, but also the fuel station owners can look over the street and see the price tag of the competitor, and they reconcile each other even without talking to each other. So the important thing about collusion is, of course, that we talk about collusion being on the legal side of the coordination. So if it is really a cartel, if they really talk to each other, yes, this is boring. That's something I'm not really interested in. And even in praxis, of course, you see situations like that, but then it's a topic for lawyers and not for us as game theorists anymore. So we are much more interested in this real legal collusion, and this works very well if, for instance, here on the Ponte Vecchio in Florence, you probably know those situations. They all have very similar prices and they all sit close together in order to watch each other, and then you have this high price level and not really competition. So Very important for us is before in practice we even start thinking about an auction, if there is collusion in place, and in theory it is then really the prisoner's dilemma between the competitors that teaches us some levers for or against the collusion. And I want to go very quick now over this slide because it's not the core of the paper that I want to talk about, but it is so important to reflect or to have in mind that even before we start applying the auction tube, it is important that we thought about is there collusion or not. And only if the levers against collusion are applied sufficiently enough, or if we see just from the analysis of the market, no, there is no collusion, then we go into the direction of auction and we do that. Otherwise, we would, for instance, go into the sequential negotiations. The whole topic of sequential negotiations starts here with the high deviation profit to really incentivize the bidders to deviate from the coordination. This is the pure deviation in the prisoner's dilemma. You know about that. So this is just a short glance on it. I could talk an hour only about this slide. I just wanted to give you an impression that those thoughts are reflected and very interesting. And this was a topic that came up at the end of Larry Samuelson's talk in October, I guess. Then he talked about the coordination in prisoner's dilemma, in prisoner's dilemmas. It is so interesting. I thought we are really looking for those criteria in real markets. And the list of criteria I work with today is this list, where I'm saying this is for me quite interesting. It's not so much the volume, supply and demand, which tells you if there's a buyer's market or a seller's market, a long or a short market. It's not about the volume. It's much more independent from the pure volume, the number of decision takers, the number of suppliers. And that's really, this then drives the opportunity for them to behave collusive. If there are only a few suppliers, then they can coordinate. And if there are a lot of buyers, then they can even coordinate better with those lot of frequency of buyers' decisions, high frequency, and so on. So this is an interesting topic, which in the paper is only touched very shortly in the introduction, more or less, of the paper, but it's very important for me. That's why I bring it up here just very shortly. B, the second precondition for applying the auction tube, or more in general, even our auctions, is that we have to be able to bring the competitors or the bidders into a comparable basis. And that's a method which is famous now in industry since 15 years about, or almost 20 years, to talk not about the pure price, but about the comparable prices. Comparable price is then discriminated, or the prices are discriminated by any properties of the supplier and their offers. And if someone gets a malus, he gets worse compared with the competition. And if someone gets a bonus, then he gets stronger. He is calculated as if he would be stronger. He offers a 50, but he will be regarded as like if he would have offered a 40. And then in this language, the comparable price language, the whole mechanism takes place. Whatever mechanism is chosen, even if it is a conventional negotiation or whatever, but in the comparable price language, the price sensitivity is the maximum, so it's maximized. And the whole aim of deriving such a bonus system is this maximization of the price sensitivity, and then to be able to negotiate in this language. Really tough by here, really the single euro counts. And then the one with a better performance gets the bonus. If he wins with 40, he gets the 50. Yeah, and he wins an auction, for instance, even if the competitor would have bid the 30 because he had too much malus. And this is a topic I would like to, since months or more than half a year, I go now already like pregnant with this idea that I want to write a little paper just describing this as a kind of a voting system. Yeah. So if you abstract now from the negotiation, and if you assume the prices to be fixed, and go more to the task and the challenge to derive those boni mali in the internal workshops where we have to come up with evaluations for certain properties, but for certain bidders, then this is like a voting system actually. And Manfred, please correct me if I got it wrong, but when I talked to you about that, I remember you talked you mentioned it is like a discriminated border counting system, because it's everyone has not only one vote, everyone has a vote for every bidder. So everyone here, the voters are the internal stakeholders in the company, the buying company, that have to evaluate. And it's like giving a vote for everyone, a higher or a lower one. And it's not only just ranking, it's more like differentiated. And there's even one more aspect. The additional aspect is that the votes have to be paid at the end. Because if an internal stakeholder says, I want to give this supplier B a bonus of 10, if then B wins, someone has to pay the 10. And internally, it could be the budget of the department of the one who gave him the 10, because B saves him money because he performs better in the production department or somewhere. So it's like a voting system where finally the votes are paid. This was precondition B. And finally, we have precondition C. Just technically, we only talk about a single lot. And of course, real world is much more complicated. Typically, we have several lots which may be won by the same suppliers or overlapping supplier panels. And then we have to combine those things. So in case of a multiple lot situation, each single lot may be still addressed by the auction tube, but still there has to be what I call a meter design. A meter design that coordinates if it's at the same time or if it is equal between the lots, and in which sequence, and the synchronization then still is something which is not covered by the auction tube itself. And the saying here is that, of course, if you don't do it right, you will have to pay the highest bill for the last point. This is a typical experience and something you have to care for. Okay, so those have been the preconditions for the auction tube. Now, what are the basic auction types we talk about? And this should be quite easy now. If I may assume that you all have kind of an idea of game theory and auction theory, I will not go into the details of the single basic auction types. This is a slide alone where we talk 2 hours or 3 hours in the trainings in business if we do it at our clients. But here, let's go through it very quick. The auction designs or the auction types, the basic auction types we use are, and I mentioned it here, those with 1 or 2 winners. And the reason for that is, even if at the end the auction tube addresses only auction designs with 1 winner, with 1 lot, but the auction design may be a design of 2 phases. And the first phase then has 2 winners, and the 2 winners just get the qualification to the next auction phase, so to say. So here, more general, if M is bigger than 1, then it is, so to say, they win not finally the business, they win just that they come further to the next phase. That's why we have here M bigger than 1 also, or big M is 2. So 1 is, of course, English auction. And about the English auction, I could also talk now along about why we are doing so lately clock auctions, or call them also ticker auctions, because we really strong believe and know from our experience that the dynamic English auction, where they underbid each other, only gives them opportunity to send signals via jump bid or whatever. It's not to the favor of the auctioneer. So we, as IFAMD, all the time only recommend and execute ticker or clock auctions. And as an English auction, this is the purest English auction if the increment of the ticker step is infinitesimally small. Of course, you can't do it too small, because in real life you have to do steps. But the smaller the steps are, the better it works. And yeah, so yes, this is a ticker. If we look for 2, then we do not only go for English auctions, which would be then a third price auction, so to say. But in practice, it turned out, and I will come back on this with some formulas, that typically the third price mechanism of an English auction with 2 winners is not better or even worse than doing something that we call a Hong Kong auction. Hong Kong auction is almost the same, but it is actually exactly the same as an English auction with 1 winner, only with 1 single difference. The difference is that the last supplier that stepped out is regarded as a winner still, and he learns afterwards that he was the last one stepping out, and he becomes a winner too. So we call it Hong Kong because it's from a footnote from Klemperer here in his book from 2004, I guess, Option Theory and Praxis. He mentions that for the sale of 3G mobile spectrum licenses in Hong Kong, he recommended, I'm not sure if as a clock auction, he recommended just a sealed bid with N licenses to be won, but as a uniform price auction, not with victory logic, but with the logic that the worst winner is the one who defines the price for all winners. And this is exactly the logic of this Hong Kong ticker, where the last one stepped out. If it is infinitesimally small steps, if you imagine, then this is exactly the price of the worst winner, so to say, defined for all. The other one is not driven further because the auction ends when there is only one confirming it. So this is what we call Hong Kong auction, and this is very famous in industrial reverse auctions if it is about two winners, or especially in such a pre-phase where two participants of a last round are defined. Then, of course, first price sealed bid, classical, just one shot, no transparency about prices, that's why it is sealed. And then we can talk about the post-transparency, what to reveal afterwards. The more you reveal then, the more is the decision commitment transported. But of course, you have to think about the bigger game. If it is probably collusion in doubt still, this post-transparency even could be not of favor. But in the auction cube, we talk about a classical first price sealed bid where the bids are opened afterwards. And then everyone sees, in terms of the comparable price language, if he's a winner, or if not, then why not? There is also this M with two winners as a pre-round, the same. We call it still a first price sealed bid just in order to simplify, but actually it's not a first prize only because if there are two winners, it's the first and the second, so to say. So it's a pay as bid auction. Pay as bid auction with two winners is just the same. And there's one variance used in the auction tube. You will see in one of the corners, we played in the variance that variation that we reveal only the rank. If it is this pre-round with two winners, then it might be that it is better to reveal just the rank between the two of them, who is in lead and who is the second, if the prices are deviating very much. So those are the basic elements. Of course, a Dutch auction, everyone knows, ticker coming from below, and the first one gets it. And then just for being complete, here in the scheme, I mentioned here's a second price sealed bid. Second price sealed bid is not really a part of the auction tube because in practice it's very tricky to do it. It's interesting. There are, of course, examples where it took place. I did it twice in my life since 15 years. And of course, you all know Google AdWords is second price sealed bid, even with more than only two places and so on. But in industrial practice, it's very, very demanding to explain it in a way that it really works like this. And afterwards, you have to tell your shareholders or your stakeholders why you didn't take the price of the best one and so on. So this is, in our context, not really a relevant auction format in practice. That's why it is here only mentioned. So the fundamental trade-off between first price and second price auctions. Before we then dive into the revenue dividend theorem, which motivates the dimensions of the auction tube and then the real corners of the auction tube, here now, just as our our tools that we use, some formulas about the trade-off between first price and second price auctions. One more heuristic picture from our training, so to say, if you imagine three bidders, A, B, and C, with some indifference price levels, which are of course different, and wherever this comes from, they might have completely different cost situations. Yes, they might have, if we don't know this cost situations and or their evaluations, which would be already cost plus margin or so. Yeah, we have to discuss then if any probability distribution of their evaluation is then the same or not. Yeah, even if they are here very different, that might be drawn from the same underlying probability distribution. Yeah, if just the variance of the distribution is high enough. And then these are three different realization topics, for instance. And yeah, in addition to the indifference price level, there is a strategic margin if it comes to a first price auction. So this should be the arrows. And now the question is for the auctioneer, what is the better result? The result of a first price auction or the result of a second price auction? And the footnote here says, yes, the result in terms of price, because in both situations, B will be the better one, of course. Yeah, if B is so much stronger, but with which price? And the question is, which is higher? The indifference price level of B plus the strategic margin or the indifference price level of A? This is the big question. And that's something I want to formalize now a little bit. Yeah, we already have seen on this very first slide for the sales side of the bidders that the relevant aspects here are the estimation of their own risk aversity and the proximity of cost levels amongst the bidders. So on the second slide of today, it was addressing the sales side. Here it addresses the buyer side as an auctioneer because he has to anticipate the bidding strategies of all bidders. So for both of them, these are very interesting evaluations and have to be estimated. So let's formalize it a little bit. The trade-off between first and second price auction. And I shortcut here, FP is first price, SP is second price. We talk about N bidders, we talk about a standard deviation, and I will discuss later about the uniform distribution, but I like much more the normal distribution, which for my feeling is much more natural out there in nature. And then also in business, typically things are distributed kind of like a normal distribution with some expectation value in the middle and some standard deviation. And this should be N mu sigma. Expectation value, of course, is E, and it might be of a distribution or of an auction design or a single auction type. Then this X, this is the order statistic. And the order statistic is a statistical operator, and this tells you, this makes out of one distribution another distribution in the way that if you have N bidders, and if you assume that all those N bidders underlie the same probability distribution concerning their cost levels or their differential prices, then you can regard those N bidders as a sample of N realizations of this equal for all uniform, not a uniform, an equal distribution, whatever distribution it is, as a sample of N realizations of it. And the order statistic is, it has a number here in the next line, it's I and N. N is the number of bidders, and I is the E. The order statistic is, if we take, for example, now the first one, the first would be if I throw the dice 6 times and a 6, and I also time out of those 6 takes the best. Yeah, then this is like having 6 tries to get a 6. Yeah. And this is, of course, a much higher probability to get the 6 than to throw the slice only one time. Yeah, and this probability to get the 6 after the N times throwing the dice, this is this order statistics. And it has so much to do with auction theory, because if we talk about a first price auction, then the best one wins of N bidders. And if we talk about the second price auctions, then the second price wins. And in a third price auction, yeah, an English auction with 2 winners, for instance, is the third price auction. There we have to talk about the third order statistics, yeah, with N bidders doing the sample, all the time the third price drives the price and so on. So that's why those order statistics are so important, and they are just an operator of a normal probability distribution, producing a more complex, but just another one out of it. Then M is a strategic margin, and we learned at the beginning it depends on the mechanism we talk about. So in the first price auction it is M, and now the important value here is G. G is the threshold for the trade-off between first and second price auction. So if M is smaller than G, then the first price auction is in favor, and if M is bigger than G, then the second price auction is better. So exactly like in this, so G, so to say, is the difference between those two here. This is exactly G. And this is the second order statistic, and this is the first order statistic. This already was the formula, So the formula is written here. G is the difference between the two order statistics. And if M is smaller than that, then the first price option is in favor. That's the whole topic. Yeah. So above here, you see the expectation value of the second price and the expectation value of the first price. Here is the plus M, is the error. And then you can derive the unequation just from the picture before. Now I come up. The first thing is, if you read auction theory literature, that of course those things are typically looked at without loss of generality in saying this mu, this expectation value can be 0. So this is something which is quite clear, because if I call it 100, 110, and 105, or 1898, or if I just draw it down to around the 0, this doesn't make a difference. It's just a transformation with an offset. The calculus is the same. This doesn't change anything. But the second step, where then typically sigma is taken normalized to be 1, this is something that destroys my interest here in praxis. And that's something where I realized that for us, it really makes a big difference if sigma is bigger or smaller. If the deviation of the prices between the suppliers, if they vary a lot or if they are close together. So in praxis, I would say the relation between sigma and mu, and probably it's much more the relation between sigma and m, which plays a major role. And if I normalize sigma to 1, sorry, mu to sigma, yeah, it's sigma. If I normalize sigma to 1, then I would have to normalize or scale the strategic margin with the same scale factor, and this would then turn it around, so to say, but this is something that must not be forgotten. So I'm saying sigma may not be assumed to be 1 without loss of generality, because it would also scale the size of it. Yeah. And the thing is, and this is already going to the revenue equivalent theorem, if we, and I bring it up later explicitly, but for those who know it, the revenue equivalent theorem says that for risk neutral bidders, the result is anyway the same in the expectation value. Yeah, but this means that M is G. Yeah. So G is exactly the strategic margin that is expected from a risk neutral bidder. Yeah, and if sigma is different, then this might be different. And this is exactly what I was interested in and what we calculated. And now we come to the calculation of G. But before that, I want to discuss shortly the uniform distribution, because some literature also just takes the uniform distribution because it's easier to work with. And here in this picture, you see what drives my interest. We have a large sigma probably between suppliers, and another day, probably the same suppliers or other suppliers with another tender have a small sigma. Yeah. And in the absolute value, this makes a difference. If it is smaller, if it is by, if the mean is the same, yeah. Which margin in percentage of the absolute value of the prices makes a difference in order to decide whether the first or second price option is better. So I am saying in praxis the relation between, and I already mentioned, it's much more the relation between sigma and m actually at the end that plays that role. But if we take the uniform distribution, yeah, typically the uniform distribution is then taken from 1 to from 0 to 1, for instance. Yeah, yeah, then the sigma is fixed. Yeah, because this has a certain sigma, this uniform distribution, and it's something that's very hard to calculate with. So if I assume an arbitrary sigma, which I want to deal with, a larger or smaller one, whatever sigma comes up, yeah, then I would have to adjust the interval HAB so that the sigma is the same. Yeah, but the thing is, this is completely unnatural. So this is a question of taste, probably. This is my gut feeling. But if I work with that, I really am in doubt. What is the speciality of such a number A and B? Why should the probability that a bidder has its cost position there be jumping from the uniform probability to 0 then? Yeah, and even if the interval is taken as an open interval, that makes it some kind of continuous. This is just a dirty trick. It's still why should it be there? So my heuristic It's really heuristic, but my gut feeling as an algebraic number theorist. Yeah, I never studied statistics, but as a number theorist, I'm telling you the natural canonic distribution for discrete situations is of course a uniform distribution. If we talk about a dice with numbers 1 to 6, which are discrete, but as soon as we talk about a continuum, then it is completely unnatural to have a uniform distribution which has an edge. Yeah, and then where should the edge be? So this should be, for my gut feeling, a normal distribution. And that's why we then really focused on the normal distributions. So back to normal distributions. And there, our concern was, or our interest, to calculate this threshold G, which is a threshold for the anticipated or assumed or expected strategic margins. Yeah, if they are higher, then go with the second price option. If they are lower, go with the first price option. And we can calculate them. So here are some formulas for them. The formulas, and the small f is a density function, and the big F is a commutative distribution function, but of the normal distribution with expectation value 0. Okay, but sigma, any sigma. And these formulas are taken from a book, Order Statistics. Order Statistics are quite complicated. And in this famous book, really lovely book, there are those lovely formulas. And Florian Rupp was so kind to calculate this on Maple. And yeah, we calculated it through for several n's and several sigmas. And then the middle came out. The middle was that G is proportional in sigma. And this is something, can I look to the eyes? Is there someone who wonders? I don't know. So I wondered completely, because if I look to those formulas with integral, and so I really tried, but yeah, it's so long ago that I was trying to reformulate those terms, and I didn't have any idea how to do that, how to prove that G is proportional in sigma. So looking to the integral formulas, no chance. This is absolutely not obvious. And for about 10 days, we thought we would have found a big result, or a minimum a Berz conjecture if we can't prove it. Yeah, but it was so clear from Maple with numbers with 10 or 20 digits after the dot being exactly the same. It must hold. Yeah, it's so clear. And then they came after via Manfred. It's so good to have Manfred as a scientific board also. You can ask him every time. He said I should call Stefan Napel. Stefan Napel then told us. He clarified that the normal distribution with variance sigma is just the same as with variance 1, and then every realization of this multiplied with the sigma. This simple formula is something, sorry for me, as not being a statistics, this was not so obvious. It is for me a question of definition. Yeah, I would not have thought that this is so clear, but it is the definition more or less. Yeah, and after that it's clear. Yeah, if I can understand every realization of the normal distribution with distribution sigma or with variance sigma as the one with variance 1, and then every time multiplied with sigma, then this is, I don't know if the English is good, but extrudes, I would say, in German, durchdrücken. It's just extrude through any statistical operators, yeah, and especially for order statistics, as complicated as they are, but every number you have to deal with is just multiplied with the same sigma. So this goes through, and then it's quite clear that G is, at the end of the day, proportional in sigma. So it is so trivial that even Stefan Napel didn't want to be mentioned in the footnote. This became a footnote now in our paper, and he asked me not to mention him because it is so trivial. For us, it was just funny that for 10 days we thought we would be here on the track of something very great. But still, it is very, very helpful just for practitioners, as I am, to have now these single numbers for every n. And actually in practice, n is only a small number. Yeah, you have 2, 3, 4, 10, more than 10 bits, you have varior. Yeah, we calculated for all n from 1 to 100 yeah, in the appendix of our paper, and then you have G. with a kind of natural constant, and this G of n you can calculate with these formulas with sigma is 1. Yeah? For sigma equals 1, we calculated it, and this is the appendix of our paper, and we have it like a table, and you can now look it up in order to decide whether to take a first or second price auction. That's the whole thing. The first 10 I mentioned here, those are the numbers, and we did it also for the pre-round when we talk about Hong Kong auction. There's a similar thing between Hong Kong and second price auction, or then English. There we call the threshold H and the margin N, because the Z is not, instead of X, we say Z is the order statistic of a normal distribution, which is already under the impression of competition. Because if you talk here about Hong Kong and English auction, then there is a ticker going down, and under the impression of competition, they reduce already probably the interference prices if they have uncertainties and learn from each other. Yeah? So this is the idea behind interference price. And at the very beginning of the day, that the interference price does not depend on the mechanism. Yes, but it depends on the information. And if the mechanism gives you some information about and where you can then probably even avoid winner's curse or so, then you probably adapt the interference prices. And after this adaptation, we call this then not X but that. Yeah, but this is still an order statistic. And here the 3 and here the 2. This difference is then just the one that gives you the threshold for the differentiation between Hong Kong and English auction. And here we also have the numbers. So far, our calculus. And now we can go into the backward reading of the revenue equivalent theorem. In the very simplest version, which we only need here, of course, the revenue equivalent theorem exists in very far-going generalizations, but for us it's completely sufficient to have it in this very simple version that is found at Klemperer, for instance, in his Appendix 1a, how he calls it in his book. Any mechanism, and mechanism is here more precise, any auction mechanism that holds that the bidder with the highest valuation wins the auction, and here it's forward logic, highest valuation, and the bidder with the lowest possible value gets 0. This is the only condition that the mechanism has to fulfill, and forgive me that I forgot to turn it around, because here, of course, for literature, it's formulated as a forward auction logic. But our mechanisms all fulfill that. So that's clear. And even any other fancy mechanism you can come up and which fulfills this has then the revenue equivalent theorem saying that under the following assumptions concerning the bidders now, they have the same expected revenue. Yeah. And the two assumptions here are the valuation of the n bidders, if there are n bidders, they have to be independently drawn from a common, so it has to be the same distribution, and the distribution just has to be strictly increasing in the accumulated formula, and continuous distribution. It has to be continuous. So a normal distribution, for instance, fulfills that, of course, and all the bidders are risk neutral. This is a big precondition for the revenue equivalent theorem. For risk neutral bidders, it says that the revenue is the same. And for us, this means the strategic relevancy of the business has to be low. Yeah? So as a proof idea, and this is now really heuristic. Yeah? This is just after trying to understand the proofs and after dealing with this G and M and everything, I come a little bit to the gut feeling that somehow, probably, and now I really don't want to be provocative, but somehow the revenue equivalent theorem is a retrograde definition of what risk neutral is. Or in minimum, it explains it. It explains the risk neutral bidder is the one that bids exactly in the way that he meets the second price option. Because this is the angle, actually. It's the second price logic. And then the proof just says, all the others will have the same result. And at the end, it's the same for all. And it is exactly so. For my feeling, you see the proof, so to say, it's this picture here, because the risk neutral is just the one who who meets exactly then this edge in average. Yeah. So if the bidders are risk neutral, they bid in average what they expect to be the expectation value of the second order statistic which is the same as their own, because they subsume that the competitors do that. Yeah, and then it works with having the same result in now first and second price mechanisms, and similar since the argumentation for all others also. Now Milgram comes up, and Milgram says this very famous quote: "One important use of the equivalence theorem is as a benchmark for analyzing cases when the assumption of the theorem do not hold." Yeah, and what are those assumptions? I'm saying the most important is, yeah, the sigma. If it's high or low, you could argue that this is not already contradicting the precondition, because if it is high or if it is low, it still can be for all the same. Yeah, so this is just one value I'm interested in. Yeah, and in the interdependency with M, with the strategic margin, then it can come to a contradiction. And especially here, if the M is lower or higher than a risk neutral would be, then this would contradict the preliminary, the prerequisite. And the third value here is the N at it all. Yeah? If you have a lot of bidders, yeah, then I can use other mechanisms than if I have only 2 or 3. So those 3 numbers are the values I deal with now in the auction tube. And to be quick with that, this is sigma M and N. A little bit confusing is this with high or low. If the strategic margin is high, yeah, then the strategic relevancy is low, and the same applies for the risk aversity. The risk aversity is low if it is not very, if you can afford the risk not to win the business, or if it is not strategically relevant. So this low is actually the high M. And the low M, low strategic margin, would be then the left-hand side. With N, it's clear, and the sigma also just widespread or close together. It's just the sigma. Now we can go through this very quick now through the edges. Here, remember, I work a lot with this formula, this M being smaller than G of N. Here is N coming in and sigma. So all 3 numbers come together with this formula that makes the trade-off between first price and second price auction. Yeah, that's why we did all this calculus up front before I now dive into the auction tube. And let's do this quite quick now because of the time. Now, first of all, the nucleus of all thinking is Klemperer, Klemperer's Anglo-Dutch. He's saying, and this is also in his book from 2004, that he recommends Anglo-Dutch as a very robust auction design. But already before we knew the auction tube, since more than 15 years, we are saying in industrial praxis that the Hong Kong Dutch. So instead of an English with 2 winners, it's more robust even to have here in Hong Kong, which goes up to the second but last bidder that steps out. Yeah, with the English, the pure Klemperer design would say an English auction to create here a market price or something. But if all but 2 bidders stepped out, yeah, then we have 2 participants of the first 2, and this is then a Dutch auction with 1 winner. And the big disadvantage is that here this ends with a third price mechanism. So if you have only 3 bidders, for instance, or if already the third one is much more expensive than the other 2, then this is finalized much too early. And in general, it's much better to go really like with 1 winner in an English auction, but the last one stepped out, gets still the permission to get further. Of course, you have to announce this beforehand. That's why it's then called an Hong Kong auction. And the last, which is still proceeding here. And then the point is, in industrial good markets, the strategic margin in a Hong Kong auction is supposed to be lower than this, this H, as we said. Yeah. And this is exactly what I already mentioned, with that being under the impression of the already declining and with transparent prices mechanisms that transport that competition. Now, taking this, we go now to the edges of the tube and go just to all 8 edges or the corners. And if we start here with more than 3 bidders with a high strategic margin because the risk aversity is low and only a small sigma, And this is the classical situation where the formula is supposed to be that M is bigger than G, and we have enough bidders, we can go just with an English auction, and this then should go through. So this is the exception case where the auction group has not two phases as an auction design, but just one phase, English auction, go to the end. This is kind of the angle point of the revenue equivalence theorem also, yeah, isn't it? The second price mechanism. Here everything is very fine and clear, and the English auctions were commented. So if only just the sigma is high now, yeah, then there is at any point the point where the equation goes the other way around. Yeah, here it was M that was bigger, and now M is smaller. Now, if M becomes now smaller than G because of the sigma rising, yeah, then the first price auction should be in favor and should be the final round. Yeah, and still, according to Klemperer, so to say, it's fine to have a first round with transparency of price and market price building fast, but only with two winners, and then the last round should be the first price auction. But due to low risk aversion still, we are here, the Dutch auction may be not accepted by the bidders. Yeah, this is now here in doubt. For pure auction designing, first price yield bid or Dutch is almost the same. What is a big difference? A little bit of information exposure also, but in the first price auction. But and another aspect is that with the Dutch, you have really this decision commitment built in, but we promise not to talk about this today. But it is then the other way around, that this Dutch auction probably is not so good accepted in some markets, and a first price you bid at the end is better, it feels just more smooth to the bidders. And that's why we here with the low strategic relevancy, we recommend actually the first price you bid at the end, yeah, even if Hong Kong was the first phase. Yeah. This equation is exactly the one already stated for arguing that this is not an English with two winners, so a third price auction, but the Hong Kong. This bubble here says that this argumentation here, I am not sure if this is already behavioral economy. This is a kind of hint to my competitors who all love nowadays to call up behavioral economics. Next corner. If we go to the left, if we have a big wide or a high sigma, and now have the strategic relevancy or high risk aversity, but still M low on the left hand side, yeah, which is a high relevancy exactly. Yeah, then most supposedly M is again smaller. Yeah, so the final phase should be first price as we had. Yeah. But now we can do the Dutch. This is a difference. Yeah, now we can do the Dutch. We have a reduced information exposure problem, and we can do the Dutch at the end, and it's the same argumentation for the Hong Kong. So this is quite clear. And if we now go to the edge here behind, then just sigma gets low, and this is now a situation where I'm saying, okay, down here again, it's in doubt probably, which is if M is above or below this edge, this is threshold. Yeah, but both sides of the equation are small. So if there is any disadvantage of the first price auction, then this might entail is minor. Yeah. So here, so to say, this is a pure Klemperer robustness that we just do the Hong Kong Dutch, yeah, before we do anything wrong. And both corners here in the left edge, it's the left back side. Now, if we proceed here, we have again a low strategic relevancy, have only 2 or 3 bidders, and we are close together. And then, yeah, because we don't have enough bidders to do something like a discounting auction, regardless if English or Hong Kong, it's just not enough bidders to really such a price building mechanism. Yeah, then the first round has to be a first price yield bid. And also the second round should be, we had this argumentation already, should be also a first price yield bid and not a Dutch. So we recommend here just 2 phases of first price yield bid. And actually this is an interesting thing. You could consider here as the second round a second price yield bid. And this is something I invented, I don't know, 2007 was my book coming out. I called it an English light there. I did it several times that time, 15 years ago. But second price yield bid is very tricky in industries. Yeah, I really had this experience also, that it typically, if you do it just with 2 times the first price yield bid, the result is minimum the same. It doesn't really work as it should be from theory if you do it in practice. So second price yield bid would be here probably even more natural as an English light, so to say. Yeah, it's the same as behind here. Here we have enough bidders to really go through the ticker, and here we would do it just in 2 rounds. Yeah, and what would be more natural than having the last round as a second price yield bid. But in industrial practice, I have the experience by years now that just keep hands off the second price yield bid. The next corners now is going up. If the prices might be differing very far, then it might be the case that if there is a big difference after the first phase, and if then I'm transparent and tell both participants of the last round where the other one is, and if the strategic relevancy is low, yeah, then I can both one of the two feel sure and the other one just being discouraged. Yeah, so it is a little bit a risk to tell the prices after phase 1 in this situation of a big sigma, and that's why here we recommend the first price yield bid with an R, which means that there is only rank information after the phase 1. Now, if we go down here, only 2 slides still, with low sigma and low strategic margin, yeah, then we can do the Dutch in the last round again. We had this argumentation already here in the back side. Why not doing the Dutch with the last 2? Yeah, we can't do in English at the beginning or in Hong Kong, but a Dutch at the end, of course, is now possible. And here now, yeah, it's the same. And here is an argumentation that we do not need the rank information restriction here, because if the strategic relevancy is high, yeah, then we do not have this risk, because even if they learn about a big gap, yeah, it is so important for them. So the one who is in behind, he now knows how far he has to go, and the other one, even if he knows that the other one is far away, he also knows that the other one knows where he is. So he has to assume that he will be overtaken still, and those will even move if the edge is big. So that's why here is consciously no R. So those have been all the auction designs. And now for the conclusion, for the rest, I have some more slides. Let me go through very quick, but just to give you an embedding of the auction tube into the total approaches we have in applying game theory in industries. And the thing is, the auction tube addresses only one of the classical competition situations. We talked only about this really neutral market, natural market, which is a buyer's market. In a buyer's market, you can really do it. And then if you then have only one lot in all those preconditions, then you can apply just straightforward the cube. Of course, we talked about pollution. Yeah, that's a market which is undermined, which could be a buyer's market in terms of volumes in the market. But we also said the criteria for collusion are much more the number of players, number of decision takers, and so on. So this is very, very important for us to evaluate if there's collusion at place. And of course, sellers markets are extremely dangerous also to act with this option there. And one thing I want really give like a perspective now here is my personal Steckenpferd, my personal agenda in the market to address game theory in industries, also in real trust partnerships that might undermine, so to say, even a sales market, but it is also in buyers markets a topic which is just on another level, to ask yourself if you want to have a competition argument at all, or if the competition argument here in an auction, you would have an alternative and so on. If this destroys probably already value before you even created it. And this is something people should really reflect. And it refers to what I have heard in the Adam Smith seminar in the last sessions. Sometimes if we talk about coordination, this is here the question of coordination, breaking out of or keeping in the coordination corner of the business dilemma or breaking out. And the other is a cooperation. And this is a cooperation, but vertically between a supplier and a customer, for instance. So this cooperation, let me just go through this very quick, is really the question. If you want to meet in the middle with your opponent, and if you call up then something like a competition argument to destroy the value and to destroy the trust already, just by calling up this competition. So this is just a comic about it. This may remind you, of course, of marriage situations, but in real business, it is really the same. If you think about meeting in the middle or calling up an auction, yeah, then the point is, it's for me like two staples of cards, and you can play this and you can move to playing the competition cards, but you will never come back. And the risk for the auctioneer is that if the competition is weak, and then there is no reason for the winning bidder anymore to meet you in the middle anymore. Probably the middle would have been better. So this is a very, very important argumentation if we are on the sales side of a bidder and we feel that the competition is probably not so strong as the client, the buyer, as the client would like to have, but he calls up an auction. And then with those argumentations, we can even argue against the auction, because the buyer has to be aware of that this rest of the pie is the pie, the portion of the pie that belongs to the winner. So if you imagine that this corner here, this indifference price of the second best bidder probably is already above the middle, and then there's no reason anymore for the winner to give anything to the buyer again, because this then really belongs to the winner. So this is to be reflected, and this is kind of my daily work with my clients. Here are some criteria for such a strategic trust partnership. It's probably going much too far for today, but as a summary and the last slide of the day, just as the application of the auction cube, today we focused here just on this very edge of the whole thing. And this is the path we walk through with our projects, and those are exactly the preconditions we also discussed for the application of the auction cube. Then, is there competition at all? Can I compare the suppliers? This is the suppliers. Is there only one lot? And then I'm in the auction cube situation, or all the other fields that we have. So, thank you for your attendance.
Yeah. Is there a question somewhere? No. Oh, Shanti, please go ahead.
Well, my question is perhaps slightly unfair because it's outside the limit of this paper. But just out of curiosity, I wonder if there is any empirical evidence, because there's a lot of information that we have to assume, so to speak, when we participate in these activities. Is there any empirical information that, say, if I were a buyer and I had some suppliers with whom I had negotiated price over the years, then I decide to go into an auction to go buy instead of sticking to my old suppliers? Is there any empirical evidence that I might come out worse than I might have been if I had remained doing what I was doing?
There are experiences that it might come out worse, exactly, especially if there is collusion out there, for instance. So we have those experiences from those on our own projects, as when we have been on the other side and kind of motivating for those collusive behavior, because this is the big art of game theory on the sales side, of course. Right. So there are experiences about that. Now about empirical statistics, how often this is, or what's the result of a certain mechanism, for instance, this is very typical that people ask for, what is the average percentage of savings that I can generate if I now go with Dutch auction or so. This is something, there are studies like this, dozens out there, but I believe that all of them are kind of not really scientific and reliable, because the preconditions of each single situation are so different And it makes such a big of difference. For instance, what was the last negotiation beforehand? Each price negotiation in industries is typically a new price negotiation of something which was already once negotiated a period before. And every saving you can calculate is by 50% driven by the result of the price negotiation before. Yeah. So anyway, you can't compare those results. And that's why I am really strict in saying this is not my business to generate those studies. Yeah. Every time when I'm asked by my clients to give them any statistical figures about what is the average saving with this or that mechanism, I'm saying no. I believe that with game theory, I reveal and I implement for each situation the best what we can get, but I have no clue what this is. Yeah, this really depends on the whole environment.
Okay. The rule.
I should congratulate to your very complex talk. It was really fascinating to me because I would like to mention two aspects. The first one is I studied some of the auction theory with Eric Muskin at Harvard, and then I'm coming back and went back from university into the healthcare system to study the negotiations going up in the prices for the procedures and so on. And during that phase, I experienced not only that negotiation and bargaining theory is very essential to the practice, even with the presuppositions you have to make concerning behavior and the conditions and so on, but also with respect to the evaluation of those who is designing those negotiations, which is the lawmaker in particular in the healthcare system, but also in the subsystem, which is called the the gesetzliche Krankenversicherung. That is a big negotiation. There are a huge number of negotiations and even auctions going on. And now my question is maybe beyond, but you mentioned it in your last table, according to the application. Usually, and Lafont and Tirol have written a book on procurement procedures. So is there a link between your way to choose for certain auctions, given the fact that very often the public is forced to do procurement procedures? In my case, you have so-called Verhandlungsverfahren mit Teilnahmewettbewerb, which is you have to select the bidders in the first stage, and then in the second stage you can negotiate with them. So it seems to me that some of your thoughts are very relevant in thinking through the kind of procurement process that that one has to follow. Maybe this is only a question going beyond, but I have to go to your slides again and think about it through. But I should congratulate to the task you have already done, because in very complex environments where the product is not so easy to define or even very complex itself, then you need always some sort of negotiations. And the question is, who is part of those negotiations might be very relevant, and not only single lots, but they learn from each other from the history. So in fact, your talk is fascinating, and it will take lovely afternoons during Christmas time. Thank you very much again.
So, and I can tell you, we have one major client now. Since mid of this year, it became really a major client again for me, but I did already projects for him years ago and did our trainings also since years. It's Deutsche Bahn, and they are under procurement law, of course. And so that's why we apply those things really in Verhandlungsverfahren, exactly as you're saying. And the point is, the Verhandlungsverfahren is only one sector. Yeah. If you really
Yes.
have to do an Ausschreibung, then no, we can think about the Bewertungsmatrix, the bonus system, and so things. But the real playground of game theory is only possible in Verhandlungsverfahren. Yeah. Then we have some possibilities, but still we have, yeah, now German words, Gleichbehandlungsgebot, and also things that, of course, shrinken us. Yeah. But the philosophy behind the procurement law and game theory is very similar. It's very compatible. It's not the same, but very compatible. And we are doing a lot of projects with them. And especially when we developed the auction tube in 2017 for Hilti, 1 year later, I got a call from Deutsche Bahn, and they asked me, at that time, my competitors were their consultants, and still I was called with the question, yeah, the Wettbewerbsbehörde, the official department that looks on what we are doing here with game theory in our tenders, they asked us if there is any scheme, and it looks so arbitrary what you do there, and we need a tool. And actually, I sold the auction tube to Deutsche Bahn already 2017. And now since this year, I have a new frame contract, and they do also the project with them. Yeah. Mm-hmm.
Wonderful, but I may add, I have experience with Deutsche Bahn myself, because they were one of the bidders of the great data center. You know, the statutory healthcare system in Germany.
Mm-hmm.
There are sickness funds as well as big physicians organizations. Some of them are monopolies, as Kassenärztliche Vereinigung and so on, but they usually have these enormous data data problems, data handling problems, and so on. So they need data centers with very high security levels. And Deutsche Bahn, they always indicated their interest because they have huge data capacities. You cannot believe how big their data centers are. And they already wanted to sell those data centers to Krankenversicherung. But they made several very stupid mistakes back in 2014, it's long ago. So, and after that, they learned obviously more that they should be more careful, and so they should congratulate to got your tool, because that's a step forward for them. But again, it was very fascinating, and I love your slides. Thank you.
Okay, I have kind of observation. A major problem in your auctions are actually collusion, and especially in an environment where there's a lot of negotiation is going on. You know, I mean, it's as you said, you know, you have a kind of bargaining situation, and then the question is whether you transfer it into a auction situation or a competitive situation, let's say. And it's all kind of problems. So there is a kind of layer, I would say, of, well, pro-collusion in, you know, it's when you have these negotiations in various levels, you know, then of course it's easier to collude, or at least not easy, I would say there's a lot of tacit collusion possible, you know, just to observe the other one. Is there a way you go through your auction procedures and, well, first, well, to define something like collusion proof? You see, in some of the auction procedures you use, you know, collusion doesn't matter too much. Maybe in seal bid, I don't know, that's just a hypothesis. With other procedures, you know, they are quite, yeah, there's open to manipulation with collusion, very obvious one.
Yeah,
so a property, you know, to rank, so to say, your procedures, well, we have already various dimensions. It could be collusion proofness.
Yeah, it comes immediately to my mind that we adapted the first price seal bid for markets like steel market, especially the steel market, which is highly collusive. But after doing our homework of bundling and bundling also over time and having a quite interesting business on table, we once tried to do it even in this collusive market as a first price sealed bid auction. Of course, not a price transparent English auction or so, but a first price sealed bid, which was already kind of brave. And then we learned after the supplier communication with the first of them that the big problem for them is the post-price transparency. Yeah, we announced that we will reveal the price afterwards. And they said, no, that's what we don't want. And they complained about that this would be contradicting to compliance or so, which is not true. It's not a compliance topic. They just brought it up. But for us, it became clear that they have a problem with this transparency of the price, and because they do not want to hurt the margins in the market. Yeah. So after this experience with the first supplier communication, we changed the mechanism and decided to do the first price sealed bid without price transparency afterwards. Yeah. So you could argue what's the sense of the whole event still. We really invited the suppliers to come to the site of us, so to say, of my client, and invited them and really asked them at the same day for a bid for the same business and everything. And they even didn't meet each other, and they even didn't get a price of anyone else. But one of them got the awarding letter at the same day. And this alone made the sense that we made this event. And the asset for the suppliers was that they were bitten, so to say. Yeah. And after we announced then this process in the new style without post transparency, then one of this, it was a stainless steel company in Italy, and when we met him, he said, yes, this is the reason why I will buy your business. Don't wonder, I will buy it. I really want to have it. But only because you promised me that you will not reveal the price to the others. And this is only because of this collusive market. Yeah.
Yeah. No, I just thought, perhaps in a more systematic way, to discuss this collusion proofness,
Yes, this slide
but there's so many forms of collusion. It's not just the collusion. It's not that there's a dimension from 0 to 1 and say, well, that's the degree of collusion, because there's so many different forms of collusion. That's the problem I can see.
We are looking for more
position, but it's not valid. Okay. Just to keep you busy. Okay, then.
Helmut,
seems like we're ready for Christmas or what?
Yeah. Gregor, I had first a question. It was a question addressing the tension between trust partnership, with a potential for collaboration for co-innovation perhaps, against trying to get a bigger portion of the pie. So looking for more or deciding for an auction. But you addressed this question very good in the summary or in the last slides of your lecture. So I have only a remark. So I found your lecture was really ordered, really well structured, and was visualized. And I will mention this point not because your lecture was very good. I will mention it from a more abstract point of view. So, for my opinion, this ordering, this being well structured, and this visualizing is an economic value by itself, because it accelerates and facilitates the knowledge transfer. Knowledge transfer, it's what we are all doing always in perhaps in industry, also in university, and in industry it is quite common to visualize and to order what you are saying, what you are doing. But it's perhaps a very good example also for university to follow your way. Yeah. It's very common in consulting industry or in consulting business, but it's not so common in it's a science environment. So thank you for bringing this in science environment. That's all what I want to remark to this.
I take it as a compliment. Thank you very much.
Eva, you have a comment, Eva? Huh?
Oh, well, no, I really just agree to it. It's really also what I would like to add to this, that I really do understand, even I think a lot of points what Gregor mentioned, even if I'm not so into the mathematics.
This was
Okay.
my aim. Thank you.
I don't think we have to discuss now science and business, you know, what the different tech are. But what Gregor did was just what we do at universities, actually, the presentation. So it was not a business presentation, I understood. It was a scientific presentation. As for the structure, I heard 1,000 times already. The structure, not the contents, of course. The contents was excellent, but the structure was how it is. But you can have a different opinion, of course. But this is how we usually present, you know.
I felt like in between because I had a lot to have written the paper before, but last night I was in the business mode of drawing down the slides again. Yeah, so it's in between some of those.
Well then, thank you very much for coming, you know, and yeah, nice holidays, good season. All the best. Stay healthy. Now this is now.
And as I learned, it was the last session of the semester, wasn't it? So we all hope that there will be a next semester.
We have to think about what we do in spring, huh?
Yeah. So
early spring or so. But well, I mean, if you have any suggestions, send them to Gregor or to Florian or to me, and then we think about what we shall do.
We would be open and would look forward to. Cool.
Yeah.
So,
okay.
Have a good Christmas. Nice
so now we have to say goodbye. It's not so easy, you know.
Thank you very much.
Have a good start.
Merry Christmas. Happy New Year. Bye.
Gregor, very good session. Okay. So. Uh-huh.